Hello, hello, hello. Hope everybody's doing well. This is Cosmic, and this is Astronomy Daily Live, coming at you every single day at 2 hours UTC, right here, right now. So, yeah, glad you could pop in. I think, um, I think Pamela Gay is on tonight as well. So, definitely check her out. No need to necessarily hang around here too long. Maybe pop in and out, back and forth, whatever you want. It's cool. If you don't stop in tonight, you can stop in tomorrow night or the next night or the next night or the next night. I'll be here, and we talk astronomy here for an hour or so, something like that, more or less. I've got my drink of choice tonight. Tonight it is once again the hydrogen hydroxide. Cheers. So, really glad to see everybody again. Everything is going well here. Nothing too exciting here, at least. But the news is all Falcon heavy. Yeah, that was really something. I think that's probably the most excited I've been since STS-1. So since the first shuttle launch, that's probably about the next coolest thing that I've ever seen. So yeah, that was all right. That was all right, and it went more or less according to what how I thought it would go down. So I guess the late news is that yeah, there something happened to the center core, but you know, thinking a little bit earlier about why suppress any kind of information at all? What does one gain by suppressing that kind of information, whether it landed or not? Um, and the only thing I could come up with, just thinking about it for a little while, is hey everybody, hey, glad to see some jumping on. Hey. Um, Yeah, I don't know, Uncle Bill. At least according to my chat, OMC Triple X still has the V. So at least according to my chat, and well, it, that that says it all, my chat. So, but yeah, just thinking about the Falcon Heavy launch earlier today. And thanks for finding that info on the video, because I gotta tell you, I gotta say that when I was watching that thing live, okay, and I was uh, watching, the two on the bottom, the upper the upper right one was the second stage, the upper left one was the center core, the lower left was one one of the two side cores. Don't know which one, but the other one was the the other side, at least supposedly, right? Four streams at once. You are ninja. You've just got to be. I don't. I'm still in a very overwhelmed state when it comes to realizing the vastness of Twitch and Slack and Discord. It's just a very huge space, and yeah, trying to navigate around. That's going to take me a little while, but I'll get there. I'll get there, and you guys will help. So no problem, no problem at all. So what four streams are you watching? You're watching this one supposedly. What other four streams are going on right now? I gotta know. This is how information is spread. Yeah, we got a lot of delay tonight. Lot of delay, but that's all right. So if you have just arrived to the channel or are watching this in the future, this is Astronomy Daily Live. Uh, and every single day at 2 hours UTC, I come on to a live stream and gather some friends around in a circle and we talk astronomy for an hour or so, maybe a little bit more. Always can pretty much guarantee an hour uh, out of out of uh, out of just me. An hour is pretty easy, pretty easy. Anyway, so the whole time, say I gotta admit, comprehension drops badly. I don't do well with spoken language. Okay, yeah, that's interesting. Um, so the video that I was watching of the right and left ones on the bottom, I kept looking at those because they uh, they seem to be in sync, and every time I would look, they the the puff of whatever they use to steer, um, puff would either come out one just slightly ahead of the other, or exactly at the same time. So that kept throwing me back and forth. It's like, is this am I are these things really that much in sync? What caught me was the fact that they were just so much in sync, and the whole way down, right? For 6 minutes, I'm trying to figure out. I'm trying to figure out. Um, okay, cool. Yeah, I was just on uh, Skylius. So yeah, she's interesting. She's interesting. I I haven't I haven't come to any conclusions about her show yet, because I mean she's pretty popular, I think. I mean, there's a lot of activity on the chat, and she seems to have a lot of fun. So that's nice. That's nice. I I don't yeah I don't have any thoughts on her show yet, but I think it's interesting that she's that popular on this kind of a subject. It's kind of inspiring. So yeah, pretty cool. Um, oh yeah, tonight is awesome hardware again too. Damn, damn. Do you really want to miss that? I mean, do you really want to miss that? Okay. Well, I appreciate it. Yeah, I started watching Skylius maybe a month ago or so, and I've caught a few of her shows. Um, Tonight's one was the first one where she was. Um, I think maybe this is the third or fourth one of hers that I've watched, and I just caught a little bit of it, and obviously it's still going on now. But this was the first time that I'd heard her um, uh, getting into some astronomical topics, um, and not just having conversations with sort of sometimes a strange chat. So, but well, it's that sounds like that kind of show, just a fun show, and that's sort of what I'm aiming for too. Is 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 just fun on a really really cool topic, and yeah, maybe not. um, popular, but maybe something can be done about that. I don't know. There's lots of possibilities, and usually if I start to think about things, um, uh, go outside of the box a little bit, some interesting things happen. So I have no problem with that at all, and I think having a show like Awesome Hardware, which is just it just sounds like fun. Uh, oh, I don't see anything wrong with that at all. You shouldn't be missing that. I think we should be getting as much fun as we possibly can in any way that we can. But yeah, I'm glad you're here. I'm glad you're here, and yeah, I like Skylius. I do. I just haven't come to any conclusions yet. So she seems to know her stuff. I can I can usually tell by how they describe things and all of that, sort of where they are uh, in terms of astronomical knowledge and experience and everything. And yeah, she seems to know her stuff. So yeah, very very cool. I'd be interested in knowing how she learned all of that, and if she's doing any kind of research or anything, or if she considers herself a communicator or an educator, because then that'll at least give me a sense of where she's at, and just getting to know her and all that. So yeah, very cool. So yeah, the video uh, turns out, at least according to you, Uncle Bill, um, I think was it tomorrow that was talking about the fact that there was a problem with the video, and it was the same thing on both screens. Damn. I thought that was a little too good to be true. No, little too perfect. And it just didn't seem right. Just didn't seem right. And it wasn't. So, yeah. But the landing of the outer two was absolutely spectacular. I kept myself I kept myself calm until those two things landed. And then I was just hollering like crazy. Yeah, just screaming. Yeah, I've heard about Wavelength Brewing. I think they were talking about it on Tomorrow. Is that right? Is that the same place? Wavelength Brewery? I think I subscribe to a Twitter that has something to do with that just recently. We're going to get a little sidetracked here, but let me see if I can, because it was just recently, so I should be able to, should be near the top, right? Top of the list. I don't know how this stuff works. Oh, there. Having on. Uh, well, I don't know now. Yeah. So that was a real screamer when the two outer cores uh, did their little simul their simultaneous little dance there and landing. And yeah, it was as I said, and maybe I said it before you guys got here, but I think that Falcon Heavy launch was probably the best thing that I've seen since STS-1, since the launch of the first shuttle. I think that was probably the second coolest thing I've ever seen in terms of rocket stuff. Yeah, that was awesome. Yeah, cool. It's probably the same place that I am not finding on my Twitter. Not finding it. I thought I just I thought I just pulled them in a little while ago, but maybe it was a little bit longer than what I recall. Cause dang it, I'm just not seeing it here. I just wanted to see if it was the same one or not. But yeah, wow, I'm just not seeing it anywhere. Yeah, Wavelength Brewing Company, and their Twitter, if you don't know it, is wavelength_brew, the capital W and a capital B. So wavelength_brew, capitals at the beginning. So yeah, that was what Tomorrow had recommended too. They wanted to. They were talking in the After Dark show about doing a show over there or something. I forget exactly what that was. Don't remember. It was a while ago. Yeah, cool. You mean a decent site, like a decent location, or a decent like website? Don't know what you mean there. Oh, and Uncle Bill, I would definitely appreciate your help getting the audio Discord going. I think what I want to try to do, and nah, I'm not going to do it tonight, or maybe yeah, we'll do it soon. We'll do it soon. There's no rush here. But I think if I use this computer, see, I was trying to use my Linux machine last night when you were I'm very nicely trying to help. I could hear you most of the time. Yeah, you couldn't hear me, and not quite sure why. As I said, I was using the Linux machine, and I didn't have any option to choose the audio input device. So I'm going to have to look on the Linux machine um, and see if I can turn that on and off. Um, but actually, if we're going to be doing this, uh, you know, having you come in on audio through Discord, then I'm going to have to be running it on this machine anyway. So yeah, we'll get that set up. As I said, I don't see any need to rush. Uh, Definitely want to get you on to talk about CalSky. So it's I glanced at it again the other day, but haven't really had a chance, I guess, to dive into it in any way. So the yeah, so the two outer cores landing pretty much simultaneously. That was a real screamer. That was pretty awesome. I like that. I'm gonna get my live stream going on my smartphone. Oh, there we go. Okay. Yeah, so it looks like I'm live over there and the sound sounds okay. Good. Good, good, good. So then we waited for the center core, and the camera on the center core um, was in the upper left until they switched to the drone ship, at which time it froze, and maybe there was a cloud of smoke, and that was it. Now that seems to happen out on the drone ships. You're landing. There's a lot of there's a lot of stuff in the air. There's a lot of wobbling around. So you lose the signal. You lose the signal. 20 seconds, 30 seconds later, you get the signal back, and you see what results there are. And so when it went out, the video on the barge, I was like, okay, all right, well, it'll come back. It'll come back. And then the hosts acted a little strange, like they heard something in their ear, and that was sort of the end of that. It never came back. So I guess my only question is, and I mean it doesn't really matter, but I guess my only question at this point is, uh, yeah, I totally agree, Uncle Bill. The drone ships, they always seem to lose the signal, right at the landing point, and that makes sense. It makes total sense. No problem, no problem. But it always comes back, right? It always comes back in 20 to 30 seconds or so, sometimes less, right? Um, but this time it never came back, and the host, acted a little strange. So it's like, well, why suppress that piece of information? It's so simple, right? Whether it either made it or it didn't. What's so exciting about not knowing that? So, but yeah, for some reason that info I don't think has been let out yet. I haven't checked in the last half hour or so, but yeah, so far we don't know what the fate of the center core is. Speculations, heard some speculations, but that's about it. That's about it. And uh, the the pretty spectacular part about the whole thing really, really, really was uh, seeing that car. Yeah, that was or that's pretty interesting. It's pretty interesting. It's so it's so Oh, Elon confirmed lost core in a live press conference afterwards. He lost the core. Okay. Well, hey, that sucks. But, and, from what I saw of the drone ship, the weather looked really nice. So, can't, maybe not, might not be able to blame it on bad weather or anything like that. So, yeah, yeah. Well, that sort of sucks. Look, no matter what, I mean, unless nothing happens at all and they don't launch, they're going to learn something. So, again, just what I'm saying about, how I want people to react to my artwork is that I just want a strong reaction. Okay? I don't care if it's positive or negative. I just want a strong reaction. So, okay, cool. It hit water fast, only feet from the drone ship. Oh man. Yeah. Experimented with high thrust landing on 3 engines, but only one lit. Ooh, yeah. That'll do it. That'll do it. That's good though, man. You as I was just going to say, if you learn a lot, it doesn't matter whether it's bad or good, right? So it crashed, but it's like now they know. Now they know. They can mark off a whole bunch of things. So it's like, no, don't do that, don't do that, don't do that, don't. So yeah, that's awesome. Very, very awesome. It's for PR, it's a little bit of a bummer, but at the same time, it's sort of like, it's kind of nice to see some of it work and see some of it not work as it's supposed to, and that that can be pretty educational, right? It can be educational. It can also be bad PR because nobody wants to see anything bad. So if there's one thing bad, the whole thing is bad. So uh, who needs them anyway? So yeah, that was very awesome and very exciting for sure. That's the best thing that I've seen in quite a while. So yeah, best thing since STS1 for sure, for sure. Yeah, and now we've got that car up there that's going out. I don't. It's pretty small, but it you might be able to see that for a while. You might be able to see that for a while if you know where to look. So might be interesting. It might be an interesting target. Um, I would think that by now NORAD would have a number for it. I would think. Um, I don't know if that falls under NORAD though. I wonder if NORAD is just Earthbound. Hmm. Don't know. Don't know. Have to investigate that a little bit. Find out because now's the time. If I, for instance, want to be able to see it like through my scope, um, now is the time because it's getting further and further and further away, and that means it's getting smaller. Its apparent size is getting smaller, which means its apparent brightness is getting smaller and smaller and smaller. So, but yeah, it'd be interesting to maybe contemplate trying to figure out if I can see that, because um, if I think I can, then I would definitely want to try for sure to be able to see it. Maybe even record it. Maybe record it, depending on how bright it is. Um, I could definitely get the CCD camera up and running, take some exposures. You'd see probably a streak of some sort. That could be interesting. Could be interesting. So, yeah, have to investigate that a little bit. It's not very big. It's few meters long. You know, I'll give it 5 meters, right? That's quite a bit. Probably not even that long. Probably about that round, I would say. Yeah, 4 or 5 meters. Yeah, I don't know. Maybe less. Not quite sure. Well, cool. Let's dive into talking about collecting data with CCD cameras. Dr. Um, Dr. Gay the other day was starting to work on her camera, uh, and that got me thinking about mine. And I think I brought it out here a couple of days ago, showed it off. So if you want to see that, just go back and take a look at that. I'll bring it out at some point again. It's an SBIG ST7 7ME. It's got a filter wheel on it, and it's uh, it's an old school parallel port, and downloads are really slow. And what I was going to do, I was going to tell you the array size, but I can look that up. I can look it up. That's big. ST7. That's big ST7. ST7 CCD system. So let's see. Trying to see here what the dimensions are. Okay, so full resolution is 765 by 510 pixels. It's a class 1. Class 1 means that well, we can look that up specifically, but it's the I believe it's the highest quality CCD that you can get. I think they're maybe not the highest. I think there might be a class 0. Don't quote me on that. Class 1 might have a couple of defects. Yeah, something like that. We can look that up. Very, very small pixels, 9 micron pixels. So the image array dimensions are 6.9 millimeters by 4.6 millimeters. And it's awesome. It's got a full well of 85,000 electrons, and it's 16-bit. So it's got a very nice dynamic range, pretty decent dynamic range. At least according to this, a full frame download is 11.5 seconds. And yeah, I would say that's probably about right. And it can cool 35 degrees below ambient. So that's something I was talking about too a couple of days ago about how keeping these things cool during the day in the summertime, they're still going to be warm. They're still going to be really warm. But if you get them at night, you can drop them cold enough, be okay. Tenth of a second is the fastest the shutter will go, and yeah, so it's I think, if I'm remembering right, I'm getting about 1.36 arc seconds per pixel, I want to say. Got that in a book somewhere. Might be a little bit more than that. Don't remember exactly. I'll have to look that up. But yeah, it's a nice camera. But she was talking about collecting her calibration data, and well, I just wanted to describe how I collect mine, because there is definitely a difference in methodologies. The so there are 3 different pieces of calibration data that you need to collect, and one of those pieces actually has two parts to it. So the first is what's called the bias image or the bias frame, and I'll mix image and frame, so you just have to put up with that. So the bias image is taken by a 0-second exposure, so it's just a readout of the CCD. No exposure time, no starlight or anything like that. It's completely closed, and it's a 0-second exposure, which means it just reads. It's basically just the um, DC offset. So that's called a bias. Sometimes it's called a DC bias. This hydrogen hydroxide is nice tonight. Must be a new batch. Um, so there's your bias. The next thing that you collect is what's called your dark frame or your dark image, and for that, you do have to set an exposure time, and you have to have a dark frame for every well, you have to have a dark frame exposure time that matches the exposure time of all of your uh, light data, your actual image of your star or galaxy or whatever you are observing at that point. So for every exposure time that you take for your science data, okay, every exposure time, you've got to take a corresponding dark. So uh, if your observing plan is such that you take a number of 1 second exposures, a number of 5 second exposures, a number of tenth of a second exposures, and a number of 2 minute exposures, then for each of those you have to have a dark frame. And you usually to create sort of your master dark frame, you take several dark frames. So maybe like 10, between 5 and 10 is usually adequate. Um, and then you just average those. So you add them up and then divide by the number of frames, and you get an average dark frame, which is your master dark frame. So you have your master bias, which is done exactly the same way. You take a number of bias frames, maybe 10 or so. The more you do, the more accurate you'll be. You're dealing with sort of not exactly random noise, but your noise isn't going to go away with averaging, but um, but your measurement of the actual bias will be more accurate with more images, and that goes for the dark as well as the next one, which are the flat frames or the flat images. And the flat images, they are primarily used to sort of measure the pixel by pixel differences in gain. So every pixel on a CCD is an individual. Each one has their own sensitivity, and they are different from all the other ones. Now, usually this is very, very, very slight, unless you have like a bad pixel or something, or either a dead one or a hot one. But usually, they're more or less the same in terms of sensitivity, but they're all slightly off. And uh, you also get a chance to uh, sample your entire optical system, all the distortions that could be projected onto the CCD um, array, any flecks of dust or anything else that'll show up. Um, Anything in your optical path that would is going to do sort of some funny things to the science data. Um, you want to be able to take that out. So that's what the flat frame does, and the flat frame is also usually done using light that is very, very broad band. So you want it to be like white light. So every wavelength of light is sort of evenly evenly put into the white light. And then that is, well, should I get into the collection of that? Sure. So flat fields are the most complicated thing, um, because what you want to do is sort of uniformly illuminate your CCD array, and you want to uniformly illuminate it because you want just sort of the defects of the optical system to come through, and any of the differences in sensitivities of the pixels to show through. And so you want to be able to look at, and that's why it's called a flat field. You want to be able to expose the array to this flat field, not only spatially flat, but also spectrally flat. So just very, very white light. And so normally how this is done in observatories is up on the dome, up on the inside of the dome, they have this big white screen, and they have lamps that project white light up onto the screen, and then they point the telescope at this white area, and they take their flats that way. Now that is the best way. That's the best way. Uh, by far, that is the best way. Um, but people like myself and people like advanced amateurs and anybody, yeah, anybody who wants to do serious astrophotography, anybody who wants to do science. Um, these flat field things that the observatories have aren't. I guess they aren't practical, but they're also just not necessary. There are other ways. There's at least two other ways that I've found. Um, one is a little bit harder than the other because you have to hurry a little bit. So that way is to, and you have to plan this. But there's a point in the twilight sky, both a point in time and a time in space, where if you're looking in the right place, I'm going to go back to the chat here. If I can find it. Oh, where'd it go? Did I erase the chat? Oh no, there it is. Yeah, I'm still here. Okay, good. So there's a point in time and space where the sky looks gray. It looks gray. Now that is more or less. I mean, it's still going to be the spectrum of the sun, but it's there's no discernible color, and that makes it a very, very, very nice flat field. So the only problem with that, of course, is that you sort of have to hurry, and you have to be on the ball because the sky conditions are changing all the time. So you have to move the telescope to sort of follow this gray area as it moves from high to low. And you need to keep track of your exposure times because those are going to be changing because it's going to be getting darker. So yeah, so you've got to sort of do two things at the same time. And it's doable. It's completely doable. I've done it many, many, many times. I will do it many, many, many more times. It's a little hard because you have to hurry. So what I've recently, and when I mean recently, the past few years, what I've recently been doing is again waiting for twilight, but much earlier in twilight. What I do is I I put maybe a double layer t-shirt over the end of the scope. Just wrap it right in front of the scope, right in front. Make it a nice tight thing. You can use I think I'm using like a bungee cord to just hold the t-shirt on there, and then you can pretty much point that anywhere in the sky and get a very uniform field. Especially, make sure that the t-shirt is taut, right? You don't want any lumps or anything like that, because then it's going to put some darkness in a particular area and lightness in another, and you don't want that. You want uniform lightness. But then you can sort of take your time. And the goal with a flat field is that you want to expose the CCD array to almost as much as it can handle without sort of going bonkers. When these pixels get filled to about 85-90% of their capacity, they start to act funny. They'll start to saturate. They'll start to bleed. The numbers will change. The terminology for that is that it goes nonlinear. So, but and the same thing happens for very, very, very faint things as well. So when there aren't a lot of electrons in the wells, you also have sort of nonlinear behavior. As you brighten, as you put more photons into that pixel, the behavior becomes linear for starting maybe about 10% and going to about 90%. So about 80% of sort of the sensitivity of each of the pixels, you can understand that in a linear way, right? If I increase the number of photons by this many, then I'm going to get maybe in terms of a ratio, but I'm going to get that many more electrons produced. So, and it might be a 1-to-1. It might be, I don't know what the ratio is, but the ratio stays the same, which means it's linear. So what you want to do with a flat field is you want to set an exposure time such that you're hitting about the 80 to 85% saturation level. So this is a 16-bit camera, okay, which means my data values go from 0 to 65,535. So 80% of that, and 65,535 is exactly 2 to the 16 minus 1. So 2 to the 16th is 65,536, and then I subtract 1 because I have to start at 0. So 0 to 65,535. Hope that makes sense. So let's go 80%. See what this is? This is something that every good scientist has at arm's reach at all times, especially when doing work. Now, while driving, okay, I will give you that. But when you're working, you better have a calculator nearby. And I don't mean those Windows calculators. I mean a calculator. Anyway, 80% of 65,535 times 0.8. So I'm aiming for a peak intensity of about 52,000 or so. So that's what I want to go towards. Now I am still dealing with twilight, which means that I do still have to deal with exposure time to a certain extent. But what I do is I realize that, okay, it's going to be getting darker, okay, which means that my exposure time is not going to be going down. It's not going to be getting less. It's going to be getting more. So at least I know what direction to go. And what I do, at least, is I'll take a couple of flats, and then I'll wait, and then I'll take a couple more flats, and I'll sort of notice what the difference is between the peak intensity. And I mean, it will have dropped if I keep the exposure time the same. So then I sort of say, okay, it's dropped by this much, so I'm going to increase my exposure time by that much. And I start taking exposures like this, and I'm watching how much it's changing each time. And what I'm actually doing is a form of calculus. It's looking at the differences, which is nothing more than a derivative. So yeah, doing calculus by watching how much the intensity drops, and then I can adjust the exposure time like that. So trying to keep it at about the 80-85% saturation level for all of my flats. And again, I take HP 41. Yeah, my current boss has an HP. I'm pretty sure it's an HP 41 on his desk. It's got the little LEDs inside. Yeah, it still works, and we deal a lot with logarithmic type of stuff, dBs, and so we're always pulling out the HP. Yeah, yeah. HPs are great. I don't personally own an HP. I never have. Um, Mainly because I've always already had one. So it's like, okay, look, I've already got a calculator. I don't need a second calculator. And when you've got one, you don't need two. So yeah, I've never owned an HP because I've never had I've never had a need for one. So bummer. Um, so yeah, so the flats, you take a number of those too. 10's a good number, maybe a little bit more if you want, something like that. And you're going to average those too. You have to average those in a different way though, because you have to make sure that all the pixel values are the same before you average them. So you have to take into account the exposure times and adjust all the values accordingly. No problem. No problem. That's how it's done. um, so then you can average those two, and then and there's I I don't I don't wouldn't call it a controversy, but I think there's a little bit of confusion between about what I'm going to say next, and that is um, in order to account for the the flat field in the science data, um, instead of you don't subtract it out, you divide it out because it's a gain value. It ultimately it boils down to a value of gain, not a value of offset. If it was an offset, you would subtract it like your dark. But this is a measurement of gain, a measurement of sensitivity. So it's a division. So when you divide these things, you don't divide by your max value being 52,000. What you do is you divide it by a this average flat field that has been normalized. And there are three ways to normalize. Um, the first way is what's called um, uh, you normalize to a volume of one. So if you add up all the values of the pixels in the entire image, that would equal one. Okay. The other way the second way to normalize is to set all the values such that their average value, the average value, is 1. So some values will be greater than 1, and some values will be less than 1. The third way is to make the maximum value, the maximum intensity, the brightest thing in this average flat field, the brightest pixel in there, be a value of 1, and then everything else fall below that. And what that value of 1 means is that is the pixel that had the least amount of gain. It had and we're setting that gain to a value of 1. So when you divide your science data, that pixel in your science data by that pixel in your flat field, the value of your science data is not going to change. But since everything is less than 1 in your flat field, when you divide, you're actually going to be multiplying. You're going to be increasing the values of your science data. So that's 3 different ways of doing it, and I've been doing it the third way. So just assigning the maximum value to 1 and letting everything else fall below. But I'm looking at a couple of books for a while, and they seem to indicate it's sort of not clear, and maybe it's just because, thick head. Yeah, no, Uncle Bill, I have no problem with reverse Polish. I think it's actually a much better way to think about um, uh, numerical um, arithmetic, having to punch in numbers. It's also much more computational, where you load register A with this value, okay? And then you load register B with this value, and then you load register C with whatever function you want, and then you hit go. And as a computer guy, that makes sense to me, rather than load a number into a register, then load a function into a register, then load a number. It's a little strange. Yeah, it's a little strange. Doesn't particularly matter, I guess. But yeah, I don't know if it saves on keystrokes or not. I don't think so. I'm trying to think. It's like if I hit 2 plus 2 equals 1, 2, 3, 4, right? And then if I do 2, 2, I guess it's 2, 2 plus, that's 3. Okay, all right, yep. Cool. Yeah, very cool. Yeah, I think the calculators are awesome, and every good scientist uh, has a calculator at arm's reach. See that? At arm's reach at all times. So that's the flat field. That's the flat field. So it's those three things, those 3 primary things. Now there's only one more thing that you have to do. There's only one more piece of calibration data that you have to take. And that is, you have to take the dark frames for your flat fields. Yeah, you got to take your dark frames. So for every exposure time that you used in your flat fields, you're going to have to take 10 dark frames and average those. So Dr. Pamela Gay is correct. Doing this at the telescope at the time of observing is going to eat into your observing time. However, however, a couple of points here. First is that, and this is actually the most important thing, and so I'll make it first for sure. It's really, really, really important to um, take your calibration data as close to the same space and time as your science data. It's because, like with your darks, okay, with your darks are sort of a measurement of your environment. And so, and the science data that you collect is also going to contain those environmental effects. You know, the temperature of the camera, the humidity, um, you know, everything, right? So taking your darks by putting your camera into a dark box, a dark sealed box, and um, taking your darks that way, uh, it's yeah, I don't think that's a good sample of your environment. I don't think you're going to get uh, as accurate darks as you can get, and accuracy is really important. Really, really important if you want to be able to measure stuff. Um, you can be intensely precise and be completely wrong. So accuracy is really, really important, and being able to calibrate your data um, fixes your accuracy. So I definitely don't agree with taking darks um, at just any old time. I think you need to take your darks uh, either before or during or after, immediately before or during or immediately after your observing run. And same with your flats. You've got to take your flats. Um, as I said, the easiest way is in twilight. So if you don't catch the evening sky, you got to catch the morning sky, and you just have to plan. And it's going to take some time. But that's sort of the cool thing too about doing the twilight stuff is that you have a limited amount of time. It's not as if you can spend all night taking flats, getting the best flats you can. Okay, you need to do it, and you need to practice, and you need to get better, and all of that. And if it eats into observing time, I would say that you're not planning your observing time very well. Now, flats, um, also there was some discussion about creating another box that has a uniform light source and taking flats that way. Just put the camera in the box and take your flats that way. Well, that's okay for uh, measuring the array and the sensitivity of all the pixels, the pixel to pixel differences in terms of sensitivity, um, any flaws, any of that, right? But if you just do that, then you're not sampling all the optical defects that are also affecting the gain, um, all the pieces of dust, all of that are part of your optical system. You need to be able to take that out, and doing a flat, that's exactly what that is for, because there are optical um, defects that you are definitely going to see. Um, so if you're not taking your flats in your optical um, with your optical configuration, that is the camera, attached to the telescope and looking through the telescope so we can see all the crap, then you're not getting good flats. You're getting a good measurement of the sensitivity of the CCD array, but you're not getting any information about your optical path at all. And your optical path, uh, you've got you've you've got to be able to take that out. Otherwise, you are SOL. You are messed up. Yeah. So yeah, all of these things do take time, um, and they take some practice, but they're extremely. If you want to do scientific research, scientific grade research, not just putzing around or anything else, but real hardcore, you know, high quality um, research, your data has to be as good. It has to be as good as at from any observatory on the planet, right? It's got to be that good. Um, so you have to take the time, and you have to do it right, and you have to plan. You have to plan accordingly, and you know uh, it just takes time, and it's really hard at first. It's really hard at first. Every time I I do it after I haven't done it for a while, it's like, man, I forget how hard this is. I really do. So yeah, and you can't take that kind of stuff lightly if you want to do, you know, either the science grade or sort of the high end astrophotography stuff. You've got to be able to take all your systematic problems out. Um, otherwise you're it's just going to be garbage, just total garbage. And well, that's no fun. That's no fun. All right, well, cool. I think that unless there is anything else that anyone in chat wants to discuss, I think I'm going to exit for tonight. This is really fun, and yeah, I don't feel any kind of burden or anything at all. Um, if you're watching this for the first time, stumbled upon this, uh, this is um, just a daily show where uh, we gather. It's a circle of friends, and we talk about astronomy for an hour or so. It's called Astronomy Daily Live. It happens every single day at 2 hours UTC. Sorry, Europe. Sorry, Africa. Maybe someday, I will expand into new time zones. But for now, this is how it's going to be, and but open open to new possibilities. And that's a lot of what the show is about, is just being open to things, ideas, concepts. This is science that we're talking about, and science is supposed to be, you know, full of questions and curiosity, and looking really hard at stuff. And if it sort of looks like something isn't quite right, you you correct yourself, and keep moving. And science is like that. It's a process fractal. So the outputs just get right fed back into the inputs, and it just goes around and around and around, and it makes all of this. And it's awesome. And so science is like that. It doesn't have a beginning and a middle and an end. It's a cycle, and it just keeps going around and around and around. And yeah, there's lots of stuff. So scrutinizing everything, being skeptical, but being very open-minded, and having a good time. Having fun, and uh, getting away from the TV and the news for a little while, gathering together with some friends to talk about a topic that you're passionate about. Hey, I think that's pretty awesome. I would definitely like to do this more. Maybe somehow I can. We will see. We will see. All right. Well, for now, I'm going to exit this planet. I've got to get back up. Somebody else is out there now, so I've got to monitor. I've got to monitor. And yeah, I'm going to look into seeing if I can see this little car up there. It's probably going to be, it's probably either going to be in the southern hemisphere, um, or, uh, or it's going to be too faint because it's too small. So, but I'm going to investigate that a little bit, and I think that if I think that I have a chance of seeing it, then I will definitely make the effort to not only uh, go for it, but I will definitely see if I can live stream that, because I think that would be very, very cool to live stream and record, of course. So yeah, we'll see how that goes. I think yeah, I don't know. I don't know. I mean, it's out there supposedly, so it should be visible, but where and when, I don't know. I'll try to find out. I'm going to try to find out. Okay, I'll get out of here. Have a great night and a great day tomorrow. And yeah, see you tomorrow. Same time, 2 hours UTC, and same place right here. And all right, I'm out. Have a great one. See you in a little less than 23. Bye.